Okay, who is having next? Next is 5194, classification of functional and non-functional requirements using machine learning approaches. Mrs. Sonali is there.
Yeah, thank you. So my research work is presented in this paper, comparing machine learning algorithms for classification of functional and non-functional requirements. My presentation will move through the outline with the starting with the motivation, then objectives, then literature review with the some discussion of the key terms, then research question which I identified after the literature review, research methodology, result, and conclusion. Let us start with the motivation. So what is the reason to identify identify certain machine learning algorithms for functional and non-functional requirement is because in the software development life cycle, we have identified that requirement engineering plays very important role, and success of the software development relies on the requirement engineering. So that is why we are going with the functional and non-functional requirement. And even it is identified that the fundamental challenge in the classification of the natural language, since requirement engineering results into the some text written in the natural language, and these requirements need to be classified or identified into functional and non-functional requirement. Even we have the new emerging fields are there, like machine learning algorithms, which are helping us for developing the intelligent software. And because of that, we are going for the machine learning algorithms. And also there is a huge support from the machine learning algorithm for the NLP processing. And because of this reason, we are going for the functional and non-functional requirement classification. So after that, we have come to the objectives so that we can go for the comparison and classification of the functional requirement. The objective is to improve the correct classification of the functional requirement and non-functional requirement, analyzing the potential of the selected machine learning algorithms, study the processing of the most selective features with respect to the selected machine learning algorithms. So with these objectives, we have done the literature review, started with the systematic review, and then reached to the specific set of the domain of the literature of the requirement engineering. And from that literature review, we started with the requirement classification techniques. We have observed that so many papers are there with respect to the NFR classification, but not for particularly for the functional requirement and non-functional requirement. But our research work where we were targeting to give the direction for both the functional requirement and NFR classification. So accordingly, we progressed to the set of some papers which are targeting the functional and non-functional requirement classification. Then after that, we identified that certain papers are there which are working on the functional and non-functional requirement classification with certain set of the machine learning algorithms, and ignoring some other machine learning algorithms. And this comparison of the machine learning algorithms for the classification we took for the research work, and we identified the machine learning algorithms and progressed through it and proposed the methodology. So these are some of the papers which helped us in identifying that there are certain papers which are relying on the functional and non-functional requirement. First paper is talking about this about the automatic classification of the functional and non-functional requirement. They are using a promise data set to expanded their data set for classification and automation of the classification. But they are relying totally on the SVM classifier, and the traditional lexical features they have taken into consideration to support the SVM classifier. They have expanded the promise existing data set, but they have also highlighted that there is unbalanced data set, and their automatic classification may get hampered because of this unbalanced data set. In the second one, requirement identification, they have identified this specific feature like word-to-vec and TensorFlow. They are using the CNN model, which is preferred for the mainly preferred in the image processing data. So this is about the classification of the requirement. Second paper is also about that. Third paper is about, again, for the used for the classification. They are comparing the VM support vector machine, KNN, MNB, and LR algorithm. They are also based on the they are also extracting the BOW and TF-IDF, but here the set of the algorithm is different from our set of the machine learning algorithms. Then there is again a comparison of the machine learning algorithm for the classification. They are using the random forest gradient boosting algorithm, and they are they are in need of a very specific data format, and restricting their data set to the existing data set they are using. Here next, classification of functional and non-functional requirement. Again, word to vec and fast text vectorization technique they are used with respect to the SVM, NB, and LR algorithm for the classification purpose. In the next paper written by Vijay again, they have used the 8 different classifiers and ensemble learning approach they have used here. No doubt this is very good way to go for the class comparison of the best algorithm, but the requirements are only restricted to the functional requirement. Non-functional requirement are not taken care by this paper. So our proposed research question here, we come up with this proposed research question: what features are to be used to cite the approach to get the better result for classifying the FR and NFR? Then which machine algorithm offers the best performance on requirement classification compared to the other machine learning algorithms? So for answering these questions, we are following this approach. We have identified the popular data set, then analyze the existing data set, which was mostly used by the previous work, and identified that there is a need for the expanding the existing data. Indeed, it is required, because in earlier paper also they are in need of expansion of the data set. Then data set used here is from the Kaggle basically, and expanded to total to 923 requirements. Understanding of this vectorization techniques, execution of the random forest and all the decision tree, logical regression, support vector machine classification algorithm, and at the end we are comparing the results. Our methodology is outlined over here. We are providing the model with the FR, NFR description. Then we are going for the NFR repository here for text processing. This data label data set is provided to this machine learning algorithms, and the training of the data set will provides us with the results and evaluation. So we are coming up with the result now, which answers our first research question: what features are to be used to cite the approach to get the better result for the classifying FR and NFRs? So these features are the backward and TF-IDF. This backward model is perhaps one of the most and simplest yet most powerful technique to extract the features from the text document. So we are going with this feature extraction technique. And second one is the TF-IDF model that combines the two metrics, the raw frequency value and the term in a particular document, and the inverse of its document frequency. So it is basically mainly working on the frequency of occurrence of any particular word. So we are going with this feature extraction techniques, and we have got the result of this feature. When we combine this feature with the specific classifier, SVM, RF, DT, and LR, we are able to see this result. And from this result, we can conclude that linear regression with both the vectorization technique is performing better than the SVM, RF, and DT. So this will will help the researchers who want to proceed with a specific classifier with this listed set of the feature extraction technique. They are able to understand the accuracy levels, score, precision level, and recall from these results. I'll go to this. This is the evaluation presented in the form of the graph. I'll go to the result 2. It is which machine learning algorithm provides the best performance as compared to the other for the requirement classification task. So since I have mentioned that we have expanded this data set, existing data set, which is available on the Kaggle, and this is the SVM, which gives the accuracy better than the DT, RF, and LR. So these are the results which I represented here in this. paper, which this is the conclusion from my research work, that linear, as I discussed, linear regression classifier is performing better with the BOW and TIFD feature extraction technique. Also, the expansion of the existing database results into the improvement in the SVM classifier accuracy. This is the future scope. So far I have taken these 4 different machine learning algorithms with the vectorization technique called BOW and TF-IDF. But in future, we would like to investigate the more feature extraction techniques such as word-to-vec or BOW, hierarchical BOW, etc., and some online unsupervised multi-view feature selection techniques. Also, we would like to expand our comparison with respect to some of the unsupervised classification approaches. These are some of the references which I took for this paper. So total altogether 22 references are there. Thank you very much. That's it all from my side. Any question?
Okay. Nice presentation, ma'am.
Thank you, sir.
Okay. There are various implementations already available regarding classification using ML approaches.
Yes, sir.
Whatever your results are there, you have just shown your results, but you have
Yes.
not compared over there with previous implementation.
Sir, I from the previous comparison, I identified only those algorithms which were not taken care by other literature. So I selected only those algorithms which were not taken care by other and included in my current research work, so as to put forth my few more options for the researchers to work on.
Okay, means just that algorithm is different, other things are same, right?
Yes, sir. And even the data set is being expanded, whichever is available right now on the Kaggle. It is expanded by 50%.
Okay. Thank you. You can stop your screen sharing.
Yes, sir. Thank you, sir.